Okay, let's go ahead and give this video lesson thing a shot. What we're beginning now is our third unit, which is about different quadrilaterals and circles, and you'll actually see how they're related, though it may seem like they may not be. So we're coming out of triangles into the quadrilaterals. So the first thing is that you need to know what a diagonal is, and I know it seems silly, but people forget. So any segment in a polygon that connects two non-adjacent, remember that the word adjacent means next to, so non would be not next to. Okay, so if you look in the background here at this shape right here, these two vertices are non-adjacent as well as those two. However, if I were to look at the orange here and then the purple here, those are considered adjacent. So if I wanted a diagonal drawn, if I wanted to draw a diagonal, I would connect those non-adjacent vertices. Okay, so now that you know what that means, it's going to come in handy later, I promise. We're going to talk about the interior angle sum theorem. So for any convex polygon, the sum of the interior angle measurements is, and here is the formula. This is really important and you need it. S represents the sum of all the interior angles, where N means the number of sides. Okay? So you take the sides, subtract 2, multiply by 180, and you get how many there are in the entire shape. So let's go ahead and work with that. The sum of the interior angles of a regular decagon. Well, the first thing that you need to look at is the word decagon. You know that that means 10 sides, or at least I hope you know that means 10 sides. So to find out how many there are total, we use our formula, S equals 180 times the quantity n minus 2. In this case, our n is 10, so we're going to go ahead and plug that in. We get 180 times 10 minus 2, which is 180 minus 8, or I'm sorry, times 8, which gives you a total of 1,440. So that means in one decagon, all interior angles will give the sum of 1440, and that's for a decagon only, okay? So we get this, that it's a decagon. Every single angle is 140 degrees. So what about this second question? One angle measurement. Well, what we're doing here is we're using a regular polygon, which remember that means congruent sides and congruent angles. So if all of the angles add up to 1440 and they're all equally, or they're all congruent, they're all equal to one another, we just take that 1440 and divide it by how many sides or how many angles there are. There's 10 angles, so we end up with 144 degrees. So this is just one angle. See, not so bad, right? Plug it into the formula, get the sum, and then if you want just one angle, divide by how many sides there are. Now, when we look at the exterior angle sum theorem for any convex polygon, so remember these are all convex because you can extend the sides and they won't go inside the figure. So if you extend this side and keep going, it's never going to cut through the interior of that figure. Okay, so all the exterior angles will add up to 360 degrees. And let me show you real quick here why. Now you see this circle put around the triangle. You know the circle has 180 degrees in it, right? So we have the circle around the triangle there. But see if you notice what happens as we move this to a quadrilateral, to a pentagon, to a hexagon, and then finally to our decagon. what you should notice, or what you might notice, is that those little arcs get smaller and smaller as the shapes get more and more sides. That's because as we move those sides and make more of them, they get closer and closer and closer to becoming a circle, which is, again, 360 degrees, right? Now, when you're looking at this exterior angle, also remember, exterior means extend a side. This right here would be an exterior angle. And then you continue in this way, extend the side, that would be an exterior angle, extend the side, that would be your exterior angle. So these three would add up to 180 degrees, and this works for all regular convex polygons. Okay, so what you need to keep in mind is that every interior angle is supplementary to its corresponding exterior. So if I went and extended these sides, like I was saying earlier, if I wanted to extend that side there, sorry, it's a little bit off, isn't it? If I wanted to extend this side, here is an exterior angle, and here, interior, and here's an exterior. Those two will always be supplementary, okay? And then you can work your way around the whole pentagon. They will always be supplementary. Now think about what I was just saying. If the measure of one interior angle of a regular polygon is 140, how many sides does the polygon have? Well, if we know that this is the interior, what we don't know is how many sides there are, so we can't just multiply and be done. However, if the interior is 140 and the exterior has to give you a total of 180, and then all exterior add to 360, then we have something to work with. So if the interior is 140, what would give you a total of 180? Well, that would be 40, right? So now we know that our exterior angle is 40 degrees. So if our exterior angle is 40 degrees, what we want to know is how many times does 40 go into 360? So you take your 360, divide it by 40, and you end up getting a total of 9. And that gives you 9, so there are 9 sides, which also means it is a nonagon. Ta-da! Now we have an exterior angle of a regular polygon is 135. How many sides does that polygon have? Well, super easy. If we look back at this example here, we had the interior, we had to find the exterior, and then take 360 and divide it by the exterior. Where here, we already have the exterior. We don't even need to find it. So we just take the 360 divided by 135, and when you do that, what you end up getting is a total of 2.67, which doesn't quite make sense, so I must have made this up on my own. Sorry. So let's say that, let's go ahead and get rid of this and say that the angle instead of 135 is 60. Take the 360, divide it by 60, and here you would end up with a total of only 6 sides. I don't know what I was thinking when I picked that 135. Anyway, ignore that. Write this. Okay, now if you're working with angle measurements, what you always have to keep in mind is that all of these angles add up to a specific amount. Now remember the formula, S equals 180 times n minus 2. Alright, so to find out how many degrees are in here, we would take the 180, multiply it by 5 minus 2, which is 180 times 3, 540. So you would take angle 1, add angle 2, add angle 3, add angle 4, add angle 5, you get a total of 540 degrees. Okay, where here you would just add the 4 angles, 1, 2, 3, 4, and it adds a 360, and then here add 1, 2, 3, 4, 5, 6, and that will give you a total of, I believe, 720. Okay, so some interior angles. Now, in the second section, we're moving into parallelograms. So that's any quadrilateral. Remember, this is just a polygon with 4 sides. Both pairs of opposite sides parallel. Now, look at these examples. These are parallelograms, and I know that it isn't marked in here, so I'm going to tell you what I shouldn't tell you is to assume. But these sides are parallel here and here. So remember the parallels, the little triangles? So go ahead and draw those in there. Those are parallel, but remember that both sets have to be parallel, okay? And the reason I say that, and now this applies for all of them, but the reason I say that is because of this example over here. These sides are parallel, however, these sides are not parallel. So this is not a parallelogram. However, it is still a quadrilateral. Same with this example. This is not a parallelogram, but still a quadrilateral, and same here. Okay, so what I'm actually going to do, I'm done with the lesson. In the class tomorrow, the next time you come in, I'm actually going to have you figure out why this formula is the way it is, and then what is figure out all of the properties that parallelograms have by doing some hands-on activities. So if you have any questions, let me know. Otherwise, I will see you then.